So I'll try my best to walk us through chapter 2, which, as Russ mentions, kind of goes over some of the basics that I think we'll need for the remainder of the book. And so this chapter, it seems to be kind of a mixed bag of prerequisites for what's to follow. And so really kind of as learning objectives, it's simply just, first kind of understanding what you need to know, and then learning just enough of those things in order to proceed with the book. I think any one of these topics, package development, working with JSON, JavaScript, Shiny, merits its own course or book, and indeed many of these topics have one or more books. But this section of the book is just going to walk us through the minimum amount of knowledge needed to kind of move forward with comfort for the remainder of the book. So just to kind of set things up before diving into the details, I wanted to step back, kind of as John does at the beginning of this chapter, and try to say why these prerequisites are actually required. And to do so, I guess I'll call back to the previous chapter that we looked at, where there are a few methods for that we identified, or the book identified, for integrating R and JavaScript. Running JavaScript from R, sending data from R to JavaScript for use in the browser, or passing data back and forth between R and the browser. And indeed, kind of these prerequisites kind of touch on those methods. For example, with package development, if you really want to integrate JavaScript as a separate script, where you'd be running JavaScript from R, for example, you're likely going to want to share that code as a package. Both the JavaScript code or library itself, as well as the R code for interfacing with JavaScript. That's why package development makes some sense to know a little bit about package development. For JSON, we're talking last week about passing data back and forth between R and JavaScript, and between R and the browser. And I think the data transfer language, kind of the common language between the two these two programmatic frameworks is JSON, right? So JSON is something that JavaScript understands natively. And luckily for us, JSON is also something that R can be made to understand thanks to a few packages, or one package in particular we'll look at shortly. For JavaScript, in this chapter, the book sets out to give us really the very, very basics of how to deal with JavaScript in case we need to kind of roll up our sleeves and actually work with JavaScript itself. Looking at where JavaScript, the work of JavaScript can be seen, kind of the JavaScript console, if I could put it that way. Understanding how variables work, and then understanding how JavaScript might interact with the data object model of an HTML page. We'll look at that in more detail shortly. And then lastly, this chapter also looks at how one can kind of, touching on this point of passing data back and forth between R and the browsers, or working in the browser through Shiny, how one can bring JavaScript into Shiny, how one can import it, and looking at the mechanisms for doing so. Okay, on to package development. I guess for package development, it's a pretty big topic. The really short version is that packages are really easy to create. So in the user interface, it's as simple as here I have my RStudio opening up a new. Actually, I don't do this very often, using more of the command line. A new package. Actually, let me look back to the new project. There we are. Come on, RStudio, don't fail me now. Okay. Guess I've been bit by the curse of live demos that never seem to work. Any event, you can create a package fairly easily through RStudio's user interface by just kind of following the file menus, selecting file, new project, new directory, and a new package, and then RStudio a lot of the machinery behind the scenes will really take care of the rest. Putting in place the requisite files, putting in place the file system, and the same can be done from the console. I think maybe often with greater ease. So thanks to the use this package, you can write something like the following: just use this create package, name your package, and specify the directory where you want this to be created, and then again R will take care of all of use this, and R will take care of all of the small nitty gritty. And for developing a package, there's actually a really nice resource that gives a little bit more detailed overview. I guess I won't go over this now, but just to point it out, there's a whole book by Hadley Wickham on developing R packages that has a wonderful chapter appropriately called The Whole Game, wherein the reader is walked through the basics, in short, just a few pages of how to set up an R package, and then the details kind of follow in subsequent chapters. So if you're interested in diving more deeply in package development, if you're not already familiar with package development, highly recommend this chapter of the book, and the book itself too. So that's kind of on the basics of how to create the mechanics of how to create a package. Then comes the question, kind of what is a package? And then I think hidden in this will be kind of how a package could be helpful for us as we're trying to integrate R and JavaScript. So the package really consists of a few disparate pieces that are linked together. On the one hand, metadata, two files, description and namespace. Description basically describes the things upon which your package depends, right? So it's like a shopping list of packages that need to be installed in order for your package to run on a particular machine. And then namespace is another bit of package metadata that basically, so whereas description deals with what the package imports from outside, namespace also deals with imports, but deals mostly with what the package exports. So of the functions you define, which are available to the outside world, to users. So packages consist of metadata. They consist also of R code, and in particular, really kind of as simple as functions that you define, whose definitions are stored in R scripts that live in the R directory of your package folder. Just as simple as that. You can have one single R script that defines all of your functions, several R scripts that define one or more functions each. But all of them live in an R script in your R directory of your package folder. Another piece of the package is documentation, and documentation. What it does, all of us, I'm sure, are avid consumers of R documentation. So for us, it really defines for any given function what the function does, what its parameters are. And then maybe some further details about maybe what the package does, some examples of how the package could be used, etc. And all of this is shifting back, I guess, to the developer side, from the consumer side, to the developer side, thanks to the Roxygen package. I presume that's how you pronounce that. Basically, the documentation can be developed in the function definitions itself. So basically, you would have define a function, and then just before it, you'd define some documentation through a few special characters, like using special comments that flag to R that these are Roxygen comments. And then maybe some tags, and there are a variety of these, like for example, @param that'll basically tell to R that you're about to define what the parameter entails. And then once you've built this into a function, written this into a function, then during the package development process, you just run a document from the DevTools library, and this will basically scan through all of your functions and strip out this information and create from this information a set of documentation files that live in the man folder of the package directory. So that's a little bit kind of the general overview for any package. And I think the part that's probably most interesting for us, at least from my perspective, this is new to me coming to the book, is that also in R packages, you can have what R calls installed files. In general, these installed files are just files that you put into the package that are kind of copied and pasted from the package, a particular package folder into the user's machine. But you can kind of think for our purposes, like this is where the JavaScript scripts or libraries will live, right? So if we're endeavoring to integrate, actually, as John has done, an existing JavaScript library with R, then you would want the JavaScript library to live somewhere within the package folder, and this is where it would live. The where is inside the inst folder of the package directory. And my very basic understanding of this, and here I think maybe we can have a discussion either now or later, is that really to have installed files be associated with your package, you simply copy them into this package directory, into the inst directory as you're developing the package. And this is undoubtedly going to be the topic of further chapters in future. You write some code that kind of links R and JavaScript, basically provides an R interface for the JavaScript, methods and functions. And then lastly, thinking back, to the description file of metadata, which is basically a list of all the things that a machine needs to install so that a package will work. You simply need to document in the description file in the special field called system requirements these external dependencies. Actually, it turns out, I think that there's no strict requirements on how this is formulated, at least to my knowledge, from Hadley's book, but it's just written in kind of, I guess you can call it human language. But this is how you can basically bring JavaScript to R, in effect by copying JavaScript script or library into a folder of your package, this specific folder, not a folder, but the inst folder of your package, and then you can kind of, this is the beginning of the process of integrating R and JavaScript within the confines of the package. Just to kind of illustrate this a little bit more, I have a few examples of, I guess, packages found in the wild. These are ones that I end up using a lot of. I've only just recently discovered eCharts for R, unfortunately, because it has some really nice stuff. I say that not because John's on the call, but because genuinely I think it's really quite nice. Here, I guess I'll just open this up from the repo. Here this is the package eCharts for R. I guess I'll just back up a little bit. You can see here the folder structure that we kind of described. You've got the R folder, which contains all of the R scripts, a few other folders that I won't explain, but then you look into the inst folder, and here you can find it looks like these JavaScript libraries. So here it looks like there are kind of two sets of things that I haven't dived into this enough to really be able to speak kind of knowledgeably about this. But if you dive down into the HTML widgets a little bit, you'll start to see JavaScript content. So eCharts for R.js, and then the eCharts for R library, I guess is version 4.8.0, and some other things. But here you can see this is how eCharts has been kind of brought into this package eCharts for R. So an R package that basically sources an existing JavaScript library, and then separately from just inclusion in the inst folder, create some bindings or like an interface between R and JavaScript. And there are a few others here that if you're interested, you can look into. But I just wanted to show one as an example of this concept in action. So that's kind of the first topic, is R package development. Next topic of the prerequisites is JSON, and it, you know, there are kind of a few topics treated in the chapter. You know, one is the topic of kind of how to make it such that one can communicate or like translate faithfully between R data and JSON data. And the other is kind of maybe the special topic, I suppose, about tabular data, how it's represented in JSON, and how one can go about accessing it with R. So in JSON, apparently, there's a technical term for kind of converting data to JSON format, and that term is serializing. Not a very evocative term, but that's the term. And effectively, you know, it means just to put something into JSON format. And it turns out that JSON format, you know, kind of in a sense might be best described as the equivalent of a list in R. And there's some really nice examples in John's book of exactly that. I'm sorry. Right. So here you've got, you know, a list in JSON, or sorry, rather a list in R. You're making some list where, you know, you have these elements of the list A, B, and D at the top level, and then for B you have nested within B a vector, a string vector C. So this is, you know, kind of a representation of data, you know, with which we're familiar in R. And then if you convert to JSON, you know, just first look at kind of the structure. If you use this function, which we'll come to in just a moment, you'll see that the structure looks very, very similar. You know, here we have yet again these elements of a list. You know, A, B, C, and then nested within B. Sorry, A, B, and D, and then nested within B, C. And then you can see that, you know, these objects, these values for each element of the list, you know, largely map to what we would expect in R, with one exception, which we can come back to. You know, here you can see that, you know, C, you know, again has a vector of string values. D has a vector of numerical values. A is one little exception, I guess, where the translation isn't quite perfect without a small degree of additional effort. You find that A is a, you know, a vector of one element, a numerical vector of one element, whereas in R, you know, this is represented just by this value. And here it's because I think JSON has this with JSON, it's wanting to kind of make this into its own like list of one. It's like singleton value, but there's a way of going about circumventing that by an option called auto unbox, which will basically make this into like a single value rather than a vector of consisting of only one value. So you can see that, you know, the list in JSON, the list in R and the list in the kind of the JSON representation look very, very similar to one another, kind of at first glance, and that the data can be made to kind of go back and forth with relative ease between the two data storage formats, thanks to this library JSON Light, which kind of, you know, I'm calling as a Rosetta Stone that you know, helps with this bidirectional translation. So you can, with a few simple functions, you can take data in one format and kind of automatically transform it into another format. So from R to JSON, you just have this toJSON function, which takes R data and transforms it into its JSON equivalent. And then likewise, you have you know, from JSON to R, which takes JSON data and then transforms it into its R equivalent. This works really nicely, but there's one topic that, you know, the book kind of draws particular attention to is tabular data. So here, I think you know, there may be a case where things aren't quite on the representation level, things differ, but thankfully, you know, again, JSON Light comes to the rescue for us. In JSON, in R, a data frame is basically a list of columns. In JSON, since it has no concept of data frame, and certainly it doesn't have the exact same concept of data frame, a list is kind of translated as a different kind of set of entities. So instead of having a list of columns, we end up having a list of rows. And the book provides a very nice graphical example of that. So here's kind of a table where we're seeing in the console the contents. You've got this tabular data, column speed, column dist, and you can see here this is how it would be represented in JSON, where you have the first row speed 4, dist 2, so it's taking the first row and making it into this JSON object, and then likewise for all subsequent rows down to the last row. So JSON represents tables differently, but thankfully you can still I'll just kind of cut to the chase. You can still get this tabular data into R as the thing that you would expect, like a data frame, thanks to JSON Light. Third topic.
Could I ask?
Sure.
Sorry. Regarding so JSON can transfer data from R to JavaScript, but my understanding, I mean, I'm not a hugely experienced JavaScript programmer, but my understanding is that there's no integers within JavaScript, that everything's a floating point number. Everything numeric is a floating point number. So there must be some, and also there's the in R there's every value is within a vector. So there must be some more incompatibilities than can, I don't know, JSON can't transfer everything that R can encode as a value. I wouldn't have thought to JavaScript. I don't know.
Yeah, that's a good question, Russ. I'm not an expert JSON Light user either. I've kind of mostly used it for handling return values from API calls, and I've not run into any instances of, or at least any instances I couldn't easily handle of kind of JSON yielding something that R couldn't easily understand, or that was like hugely unexpected.
Okay.
I mean, that being said, I mean, I defer to definitely to others who might have more experience in this area. I mean, the one area that I've struggled with personally is with very complicated, like very hugely nested JSON objects, getting back something useful in R. And so I've often, I guess for the simple things personally, I've used JSON Light. For more complicated things where I guess I know the schema of data storage very well, I've used another package called Tidy JSON, I think it is. I'm not sure if this is still being actively developed, but I've still found it very useful. Like in effect, I guess the short version of it is I think you can kind of navigate down, like imagine that the JSON object is sort of a tree. You can kind of navigate down the tree and select branches of the tree, and then have that return to you as something reasonable in R. Whereas I think, at least to my knowledge, with JSON Light, sort of you get back what you. I think JSON Light will kind of flatten the tree structure a whole lot. And then a lot of the data manipulation you'll have to do might be kind of going hard and heavy with something like TidyR, taking a lot of nested values and then kind of pivoting them long to the kind of representation you might want or expect in R.
Okay.
But as to like the actual values themselves, I've not run into anything. Maybe John John has run into something like that. Where,
JSON is particularly useful because as you've seen there, it's plain text. You can just read it, right? A bit like a CSV. CSV is admittedly a bit more difficult to read, and in that sense, there's not really a type to anything, right? And that when whatever program reads that file in, it's going to have to make some interpretations. And I think, Russ, you're right. There are no integers in JavaScript either. And I think it's a bit, yeah, there are no JavaScript, no integer either in JavaScript. I think, at least to the best of my understanding, this is just number. That's what they have in TypeScript as well, I think.
Okay.
Yeah, but that
thanks.
Does never cause an issue, really.
Yeah, so then I guess, John, what you're saying is JSON Light kind of makes reasonable assumptions about what the thing should be represented as in R.
I think it has to make, I guess, some decisions on some things. Some of them, of course, make total sense. But I mean, like a factor is going to be a character string, of course, stuff like that.
Right. Right.
I've really, honestly, you can trust JSON Light. I've never had any issue with it. It makes the right decisions there.
But am I right, John, that like the typing kind of recording the things as a type, that's kind of a post-processing task in R, really? I don't think JSON Light offers any.
That's what I mean, you put in words, you say it much better than I did. That's what I tried to say. There's just a plain text file. There's no types obviously encoded in there anywhere. And that's done by when JavaScript reads it, it makes its own decisions. When JSON Light reads it, it makes its own decisions.
Got it. Yeah, I guess for this, maybe I should spend some time kind of working through the examples, but I kind of encourage folks to look at the examples. They're really nice examples that kind of show the concepts of this translation between R and JSON. But I guess here in the notes, I wanted to provide more than anything sort of an intuition and an overview, but definitely have a look at the examples. They're very helpful.
I have a question about this part. What kind of content would be in this file that moves over? Was this like actual data, or is this interactivity, like directions for interactivity on the website? Does that make sense? Like what content are we actually serializing?
That's a good question. Maybe I'll have a quick go at it, but I suspect that others will have a far better answer here. I think it's really any kind of content. It could be, bona fide data. Let's imagine you have some data table in R. I mean, you could kind of take that and transfer it, but then you could also, I guess, process the inputs from. Here I'm thinking kind of within the Shiny framework, like inputs from Shiny, you might be able to kind of grab those directly and then convert them from JSON to R if you needed to. I don't know. Maybe others more experienced have a better answer to that.
Okay, thanks.
Arthur, if you don't mind, I was going to add to Ryan's question. So I guess the thought I would have to support what Arthur was stating, think of data coming from any form, right? It could come from your mobile device and using an SQLite sort of database, and you're reading off of that. It's a CSV file. It's a Postgres database, a MySQL database, an Oracle database. It's CSV file, Excel data. Just the input of that and the concept of serializing what form you have and then putting it into another more common form between R and JavaScript. That serialization from one application to another, the process of that transfer, that's what the JSON Light package is doing, or even to Arthur's benefit, the previous comment that the previous package he was showing. Serializing, the term is kind of vague. You're not serializing anything, you're just changing its format, you're changing its protocol. The method of interpretation from one application to another. So to a comment that John made earlier, and I can't recall if it was in the written text that he put for the show, the notes, or if it was a comment that he made, but API calls. And so API calls, a really great example of not bad JSON, but really, really super nested JSON. And it's a good exercise in a lot of places, is weather data. So if you go to AccuWeather or NOAA or some of these other weather sites, you've got a bunch of IoT devices generating a huge quantity of content stored on this server, and you need an API call to extrapolate it to your machine. Now, again, Ryan, to your comment that serializing is taking it or using an API call to take it from one server and then putting it local to your machine, it is going to come out as JSON media. So using the JSON Light or other packages, you would, flatten it into more of a data frame that would be more familiar within your R environment. And there's topics between whether a data frame is a good thing or if you want to use data.table. There's a whole school of thought related to the manipulation or management of that memory space, the data that you've ingested. Does that help, Ryan?
Yes.
Okay.
Appreciate it. Thank you.
Yes, sir. Yeah.
Great. Thanks for the comments, questions, and discussion here. Definitely, I now want to go back to the basics with JSON after this conversation. Next topic is in the prerequisites is JavaScript itself, and the book kind of gives a few sets of I guess basics on a few dimensions. First is kind of see where one could see both JavaScript itself in action and also see the things upon which JavaScript could act in the case of a web page. And then the chapter goes on to talk about details of how to understand variables and kind of assignment of values to variables in JavaScript as compared to R, and then looking in some detail at the document object model. So I guess I'll start first with the developer tools section. Kind of understanding how you can see where JavaScript lives and kind of the neighborhood in which JavaScript lives, if I can put it that way. So really, the key insight here is that with pretty much any browser. I happen to have Chrome, but I think a lot of most browsers these days are built on top of Chrome. You can easily inspect the page. So I think as a keyboard shortcut, at least on Windows, which I'm using, Control-Shift-I, and then you can basically have the notes here. The book down is itself a web page, and so I can inspect the elements of the page. So first, open the developer tools, and then you can look in more detail at this web page, and kind of the way in which the web page is actually structured. And there are kind of two different views of interest here. There are lots of other things going on, but I think for our purposes, at least for now, the most important parts are these views here. You see here at the top, I've got elements and console. So elements basically gives me access to the whole document object of this web page, and I haven't done this in a while, so I'll be doing a very poor job of overviewing. But I think you can select different aspects of the site, see kind of where the corresponding elements are in the document objects, or alternatively, you can just kind of expand this really nested object and look through the various components of the object. You've got the HTML document, which has a head and has a body. You can look and see what's in the head. You can look and see what's in the body. That's probably in most cases the most interesting parts. And this will come in useful later. You can see points at which there are little script tags where actually this website is loading some JavaScript scripts. You can see here script source, and then it's pointing to where the JavaScript is. So that's on the elements. Then on the console side, my kind of crude understanding is that here you can see basically, think of this as sort of in an R console, you can see, you can execute commands and you can see messages and errors and warnings, and you can, as well as printing to the console. You can the same is true here for the browser. So as you're executing things, you can see what issues have arisen. There's be some issues maybe that aren't JavaScript, but there may be many other messages that are related to JavaScript's output. And in fact, if you're trying to understand better how your page works, whether it's a basic web page like this or something more interactive like Shiny, you may even be able to just as you can kind of print out values to the console in R as maybe you're debugging in a kind of a crude fashion, so too could you kind of print to the console in JavaScript just to see what the nature of certain values at a certain point in time, and see what the page is doing, and assess how that kind of compares to your expectations. So that on the developer tools. Actually, the other point too is that the RStudio IDE is built, since it's built on Chromium, allows you to use these same developer tools or something very like them as you're inspecting kind of things that RStudio produces. I think you could also look at RStudio's UI itself, but probably more interestingly for us, if you're launching a Shiny app from RStudio, then you could kind of use the developer tools to inspect different elements of the Shiny app and kind of see what things are called, and whether the HTML that your R code is producing is actually is indeed what you expect it to produce, right? That on developer tools. Shifting gears now to JavaScript. This section of the book really, at least to my lights, kind of tried to explain JavaScript variables by the way in which they differ from R's variables, right? So there are two ways, kind of two big buckets of the ways in which variables differ across JavaScript and R. First is declaration, so how you declare a variable, and potentially assign it a value. And then the second big bucket of thing is the scope of the variable. So starts first with declaration. So one thing that's interesting in JavaScript, different than in R, is you can declare a variable to exist without actually assigning it a value. So you can say, you can create a variable X that is let's say a string variable, and just declare that the thing exists, just declare its type, and then that's it. And then at some later point assign it a value. And within JavaScript, there are three ways of, there may be more, but the book covers three ways, I guess in the most modern version of JavaScript, to declare variables. And they each have kind of their own subtle differences. So with var, you say var x, for example, to define the variable x, you're creating a variable that's global in scope. So in that sense, it's maybe a little bit like creating a simple variable in R that exists within the global environment, right? That's accessible by everything, and it's in that environment. Let allows you, so let x equal 5, for example, is a way in which you can define a variable, but where the scope of the variable is restricted. I'll come to that in just a moment. And then the last way in which you can define a variable is you can create it as a constant, like an immutable value. So you can see, let x equal 5, and x is always equal to 5. There's no way of changing its value through any other kind of operations. So those are the three distinct ways in which you can create a variable in JavaScript. Now I'll come to the second big bucket of differences is scope. So first, what do I mean by scope? Really kind of I have a struggle with this explaining this, but it's kind of the extent to which a variable is accessible to other things within a script. So for example, if the value, well, I'll leave it at that, and hopefully the idea will develop with a few examples. So which scopes does JavaScript have, and then how can each one of those scopes be kind of understood and as compared to what we all know from R? So variables can have global scope. So for example, if you define something var, the variable will have a global scope. So it's sort of like an object in R's global environment. At least that's my understanding of the thing. Also, variables can have function scope. So again, like with R, if you define a function if you define a variable within a function, that variable is not accessible from outside of the function. It's only accessible from within the function, like the environment of the function, as the function does its own work. So similarly, JavaScript has this function scope. And then last scope, which seems to have at least to my knowledge, no real equivalent in R, is in JavaScript. You can have block scope. So basically in JavaScript, as you're writing, I think this is a very crude way of describing this. This is my own crude understanding. If you write something and it falls within brackets, then that is considered a block in JavaScript. And then a variable defined within those brackets is only accessible within that block, not outside of the block. So those are kind of and I guess another helpful document here that I stumbled upon when kind of preparing these notes is this W3 School's little article on JavaScript scope. So it provides a few nice examples. So if you're so inclined, have a look, and hopefully it'll be helpful. It certainly was to me. Right. So in summary, kind of three different ways of declaring variables in JavaScript. JavaScript has a few different scopes. Most of them are like those in R, but there's also something new, this block scope. Kind of last topic within JavaScript is about the document object model. And so here, I'm not a web technology expert, but so this is kind of my understanding of things, is that the document object model is basically, you can think of a web page as a document, and that consists, that's structured in a certain fashion, and that structure is this document object model, and that document object model is basically kind of a tree of elements of things. Like here's the head, a paragraph, etc. That comprise the page, and then each one of these kind of elements or objects in this tree, have kind of like one or more of the following attributes. I think all of them have an ID. They may have tags, classes, etc. Again, I kind of when in doubt. Oh, whoops, sorry. This is the nice example from John's book. You think of it as a tree as follows. Here you have the document. The document consists of an HTML object. The object itself can be decomposed into a head and a body. Within the head, you have the title. Within the body, you have like an H1 heading, a div, and the div contains a link. So you can represent a page in that fashion. So all web pages are described in that way. So kind of going back to our developer tools here, you can see that the book itself, which is a web page, or rather the notes itself, which is the web page. We can actually look through. We can look through this and see here. Here's a div. a div within a div, etc. So there are lots of different objects that compose the page that can be identified in a certain way. Sorry. And so that's all well and good that pages are represented in that fashion. Well, how does that help with JavaScript? So it turns out the JavaScript, again, according to my really rudimentary understanding, is able to kind of identify elements within this document object model within the page. Select either an individual element or kind of query and select all elements that kind of meet a certain criteria. You can change the kind of like content and or attributes of the element. So for example, John has a really nice example in the book of just changing the text, finding a paragraph within the text, changing the text. So JavaScript can access that paragraph and then change its contents. Or you can even see things like changing attributes. So for example, when I hover over the elements of the table of contents, this is I guess the CSS changing or invoking some CSS. So basically on hover over, just have the text which previously wasn't colored be colored in blue, for example. So JavaScript can manage all of that. And again, really nice summary in W3 Schools, which I've linked here about what is the document object model with a nice example and then some actual discussion of how JavaScript could access various elements of the document object model, either selecting things by their ID, selecting things by their class, by their tags, etc., and then doing things to those elements of the page. Right. On now to kind of really, I guess the reason we're all here, one of the big reasons we're all here is Shiny. So the question becomes, how do you import import JavaScript into Shiny? The book outlines basically two ways in which this could be done, and this kind of touches on Ryan's question on Slack, or at least my understanding of the question. So there are two ways you can do it. You can kind of serve files, or you can use HTML tools. So we'll look at each one of those in turn. So the first one is serving static files. So you can kind of think about it this way, that for many web pages they have you have kind of the plain text that constitutes the web page, and then you may have other assets that are brought into the page. Those could be simply images that are loaded, CSS style sheets that dictate how things should appear, or should appear upon certain events, and then JavaScript. So these files kind of, for most web pages, I guess sit within kind of a folder, or at least for us for Shiny, sit within a folder where they can be accessed and made available to the web pages as the web page is rendered during a Shiny session. So Shiny basically serves serves up that content, and harkening back to our options earlier, either you can, the default is option one, is that if you're running a Shiny app within RStudio, or I guess RStudio Server and the other professional products, when the Shiny session is kind of instantiated through this command run app, the default behavior is to look for static files, images, style sheets, JavaScript within the www folder, where all those files are made available to Shiny, to our web page. Option number two is basically to point Shiny to where it could find those files, in a place not this, right? And maybe point Shiny to where to find particular files. So let's imagine all of our JavaScript files are in a JavaScript subfolder, all of our image files are in an image file subfolder, etc. So how would you use this? Both of these are kind of options for loading static files into Shiny. This is kind of done by default, so it really doesn't bear much explanation. This, at least to me, was new. So basically, how would you use this? Add resource path. So it's a function, it's a Shiny function with 2 parameters, and the one parameter, actually in the reverse order in the function, but to me it makes more sense to explain them this way, is directory path. So it's where to find the Shiny files on your file system as you're creating your Shiny project, and then the prefix is kind of where to make these files available, as kind of like part of the URL of your page, so you can kind of like see those things directly. So file path on your system, and then kind of using terms, file path on the URL. So that's kind of how to understand the function. The function just creates, points Shiny to where the files, the static files are. Where do you place this within your Shiny app? So you place it. I think it's very helpful to think about how this would be if this were just just a regular. It's more in a Shiny app, but we're just like a hand-composed HTML file. So within that, typically you'll find within the head tag, you'll find a script tag that points to the source files. That's the way it would be on many web pages. And in Shiny, basically mirroring that concept, we would want then the files to be served within the the UI, which is basically kind of the raw page. So you'd place it within the UI element and within the UI. And then you'd create some tags to mirror what you find on the HTML page. So to create a head tag, within the head tag to create a script tag that points to where your raw files are, and then so that these files are served only once, you'd kind of wrap that with this singleton function from Shiny. For this, I just kind of want to provide an overview. Again, it's really helpful, I think, to look at the nice examples John's put in the book. As for kind of organizing, we've talked about files without making too much difference between the type of files. John kind of points us in the book to sort of some standing best practices with that are like they're recommendations, not hard and fast rules. Your Shiny app won't break should you fail to follow these rules, but should you fail to follow these rules, perhaps other web developers might be confused. These are conventions. So it's useful to kind of organize your static files as follows: to kind of have a single folder that contains like the collection of them. Common names might be assets or static, and then within that folder to have subfolders that would kind of be by types. You might have a CSS subfolder, a JavaScript subfolder, an images subfolder, etc. And that way you can organize your content as you're developing your app, and then serve it to the page. So this is the model of serving static files, where basically you're pointing Shiny to where your static files live, and Shiny will, upon loading, will load those files, make them available to the page. That can be done. There's also another way in which this could be done, is using the HTML tools package. So what does it do? Really the simple stuff that it does is kind of help construct HTML tags. But really, more importantly for us, it helps with importing some of these files and managing dependencies, particularly in cases when there may be some difficulty with the dependencies. So how does it kind of deal with? Whoops, sorry, a stray click. How does HTML tools manage dependencies? So it provides so just as packages have dependencies, our packages have dependencies, JavaScript libraries may well have dependencies as well. So R kind of provides an interface for managing these dependencies. You create basically for R a dependency object through R, and then that gets resolved as kind of this HTML dependency script that you might find in our traditional web page. So that's one thing that it does. The other thing that it does to help manage dependencies is it basically can help point to, and this is I think quite useful and interesting, is if you're using R packages that depend on JavaScript libraries, for example, it will help, at least this is my understanding, will help point to where those JavaScript files live in your package folder, so an inst directory, and we'll construct them kind of as relative paths, which is quite useful. You don't have to kind of hard code this. HTML tools helps you deal with this complexity. And you know, where does this need to be put? So I guess there's kind of two use cases here. One is Shiny and another is R Markdown. You know, in Shiny, you want to put it as we did for serving static files. You want to put it in the UI element, and in Markdown, just in some, at least my understanding is some evaluated code chunk. So now we have two kind of competing ways in which we could serve static files like JavaScript to your Shiny app, and so the question then becomes which one should you choose and why? And I think the points John makes in the book, as I understand, are as follows. So first, in a sense, I think we should prefer HTML tools over serving static files. The reason being is that this way of serving files is available not only in Shiny, but in R Markdown. So it's kind of like a learn once and use in many places type setup. Whereas, you know, serving static files is the approach that we looked at is only available in Shiny. So here, you know, if you learn how to do it with HTML tools, you can use the same techniques across two output formats. And the other reason to prefer HTML tools to serving static files is that it helps in kind of evaluating dependency conflicts. So if let's say you have two JavaScript libraries or two packages that utilize JavaScript libraries, you know, this HTML tools can help you evaluate, you know, whether there are any conflicts between the two libraries, the two external kind of JavaScript libraries. And yeah, so that's why to use HTML tools and why to use this, you know, add resource path. You know, it can be useful for loading some of the things we talked about, you know, JavaScript and CSS, but it can also be used for many other, you know, any other kind of type of static file, you know, that you might want to use in your app, such as an image or maybe some JSON data that's kind of stored within your Shiny app and served as you run the app. So yeah, I think that's for me. I don't know if there are any questions or comments or yeah, I'll turn it back to you guys. Thanks.
Okay, does anyone have a question? HTML dependency is I've only really heard about in the past couple of months, to be honest, and like have been serving files using you know, just by having Shiny pull them in out of the www directory. It does look, to be honest, it looks rather complicated to me. But yeah. So
I was doing the exact
in some way it can deal with conflicts, but I couldn't quite understand how it would be able to detect conflicts between, you know, if the same JavaScript library was pulled in twice or something like that.
Yeah, I'm not sure I fully understand. This is something I didn't have time to delve into. I did hear John, I think John chiming in. Perhaps he wanted to offer something on this point.
Yeah, I was doing I actually did this exact same as Russ said for most of my packages. This is how I did it. It was much easier to simply serve a static file and then import it in the front end. And then I did I think it was a Twitter poll asking people, and actually I was apparently we are wrong, Russ and I, and we should use HTML tools. That's when I started looking into it, and straight said these fancy things. The one thing is another package can reuse your dependency. That's how if you build a package that uses jQuery, you can simply make sure you you get the same version or dependency as Shiny, for instance. That way, you're not going to you prevent already a clash there, where you're not going to start importing your own version of jQuery, which might be different, etc. And then on the clash, I hope I'm not saying something stupid, but I'm pretty sure I've seen it. Just like if it's the same name and version, it's not going to import it twice. Hence you can, even when you're going to build a package, for example, if you build a package that depends on jQuery, you're going to have 5, 10, 20 elements that are going to depend probably on jQuery. And if people use all 10 of these elements, you're not going to have 10 instances of jQuery imported inside in your browser. It's just going to be imported the one. So even like that, as it's not ideal anyways, because you'd have to make sure that the version match, I think, and the name matches. But already there, I think it's not too bad what it manages to do, because given all the JavaScript that we unknowingly insert in our Shiny apps and our Markdown documents, we should see, I think, a lot more clashes than we actually do. But it's thanks to the system that we don't. But yeah, it is convoluted, I think.
So John, I guess to kind of follow up on your point, I mean, should we understand, like, you know, the beauty of HTML tools is, like, first, it prevents from, you know, as you said, let's say you have, you know, 5 packages that each use jQuery, that you get jQuery kind of loaded into your page 5 times is kind of a, you know, that's one thing. But then the HTML tools also helps you handle, or at least, you know, handle, but help you notice if you're looking, these cases where, you know, package number 1 uses jQuery version 1.2, and package number 2 uses jQuery 3.5, you know, etc., where, you know, maybe there's some breakage between the versions.
I'm not sure it's gonna find it for you, but you can. I mean, a real example that I have is simply, for example, in JS4R, you can plot a map using leaflet. And so what I simply did is I got a leaflet dependency, put it in the package, and then someone used it along with the leaflet package, and everything fell apart. And that's when I realized that there was actually, in fact, no need for me to bring the leaflet dependency in the first place. If you want to draw using leaflet and JS4R, well, I get the dependency that you have for your leaflet installation. So for example, that's one case. And I think with those, they're very, maybe I overplayed it in the book, they're very rare. And I think for the most part, you find them the hard way, and it plays the part, you know. You can't really anticipate all of these conflict of integration of all these things, but you'll find them out eventually.
Well, it's encouraging that Russ hasn't stumbled upon one yet, so maybe that's hope for all of us.
Maybe I haven't realized. Yeah. What else have we got? Ryan mentioned a video in the chat that kind of describes how JSON Light converts handles conversions of data frames and things, which might be useful. I'll post the chat from today into the meeting notes. Yeah, if anyone else has any questions, otherwise, would it? Ryan S had a big question. Would it be okay if we talk about that in the Slack channel rather than on Zoom?
Yes, absolutely. Yeah. Either in a Slack channel, or we can address it next week if there's time or whatever.
Yeah. Well, actually, yeah. I mean, the chapter next week, chapter 3, is a relatively short chapter, so it may be a good place to discuss, you know, best practice type stuff. Yeah. So we don't have a speaker yet for next week, a volunteer. So if anyone does fancy doing a talk, you know, there's loads of scope, and there's a kind of sign up sheet on the pinned to the top of the Slack channel if anyone wants to sign up for that.
Russ,
yes,
if you would like, can I throw my name into the hat, or I'll
yeah.
go to the Google page too, just announcing it to everybody, if that's all right.
Okay, cool. Yeah. So yes, so that kind of starts up the part 2 of the book, which is the kind of the first kind of large kind of project oriented type bit of the book, which is most of the examples are about kind of wrapping data visualization tools for into which you can pass data from R. So yeah, the chapter 3 is a kind of introduction to HTML widgets and how it was used by DT as the JavaScript data tables library, and a couple of other examples as well. But yeah, if you're happy to do that, Ryan, that would be great. Okay. Brilliant.
Would you mind, Russ, if I asked, I know we're over time, but if I ask kind of a question to John?
Yeah.
I was just kind of curious, how do you go about finding JavaScript libraries that you want to wrap? Kind of what's you just see something cool on the web, and or do you have a more like kind of a formal process for it? I mean, feel free to, we can answer this in Slack or not at all, but I just thought I'd take the advantage of your presence.
No, it's a good question, and thank you for what you've done today. I think I'm a bit annoyed that you explain some stuff better than I do in the book, but yeah, for finding stuff, sometimes, yeah, it's just you find something that's a bit shiny and cool, and you're thinking, wouldn't it be nice to have it in R, make it accessible from R? And other times it's just need, right? I have something that I need in Shiny, or some visualization that I really kind of want to do and it's not available, and that's how I go about it. And then if I may just require, I know that the introduction it's a bit, I think it's a bit too shorter than it should be. At least that's what everybody's told me, and it's kind of on purpose, because when I read technical books, that's where I actually close the book forever. Frustrated, and so it is also because all of that stuff I have. Thanks, Ryan. All of that stuff I have learned myself, and I thought that as you go through the book, the examples sort of ramp up a bit in complexity or difficulty rather, and that's how you kind of learn. I hope that people sort of try at least to do a bit of what's done in the book and learn with it essentially. I think that's the best way to go about it. And the next chapter is indeed it's extremely short, Russ. It's if you go chapter by chapter in the book club, I'm not sure this chapter is exactly.
But I think that I mean, it works out quite nicely in the book clubs to have a few short chapters, because it gives us a bit more scope to kind of, you know, experiment with things and discuss kind of connected technology and stuff like that. But yeah, it's really good of you to come along today, though.
It's my pleasure. I'm happy to come to others if it's okay, you know, because
honestly, yeah, of course.
I'm just here to see a bit what people so hopefully the second edition, and hopefully what people get, what people don't. So honestly, I'm not here to hijack the session. Talk like I'm not here, and feel free to bash the book if you want. I'm sorry for the typos. Seriously, there's too many. There should be fewer typos in there, but you can get a shot of whiskey for every typo if you want to spice things up, I guess.
Right. Cool. Well, I think I ought to draw the meeting to a close then. Thanks everyone for coming along, and Arthur, thanks so much for putting the meeting notes together.
Sure.
Great. I'll hope to see a few of you all next week for Ryan presenting on the HTML widgets introduction. Great. Okay. Fantastic. I'll see you all next week.
Thanks, Arthur. Thank you, everyone.
Bye-bye.